All right, so now we're going to look at the combined gas law. And so hopefully you have already, you feel comfortable with the three gas laws that we covered the other day. And so now we're going to look at the combined gas law, and we're going to kind of take all those equations and look at them together. So this is going to be in reference to page 107 for maternity leave plans, the combined gas law. Our state standard is P.12.10, and we have 4 questions that we're going to answer. How was the combined gas law derived? How do you solve for a missing variable? What must you always pay attention to about units? And then what do you do if you don't use a variable type? The notes today are going to be very, very simple. And we're going to do 2 practice problems with them, and then I think that you're going to feel successful with combined gas law because you can do the others. Okay, so we're going to set this to the side for a second, and we're going to just remind ourselves that we've learned 3 gas laws so far. So we learned the gas law P1V1 equals P2V2, and we know that that was an inverse relationship. If the pressure goes up, then the volume will end up going down. We also learned about P1 over T1 equals P2 over T2. We learned that the temperature had to be in Kelvin, and we learned that this was a direct relationship. So if the temperature goes up, the pressure will also go up. And then finally, you learned about V1 over T1 equals V2 over T2. Again, the temperature had to be in Kelvin, and we know that this is a direct relationship, so that if temperature goes up, volume also goes up. So this is called the combined gas law, and they all had to do with pressure, volume, and temperature. So one of the things that maybe you'll notice is that we're seeing a lot of the same letters over and over again. Well, something kind of interesting happens. In the combined gas law, we can take volume and temperature law, and we can take the pressure and temperature law, and we can take the pressure and volume law and overlay them together, and together get the combined gas law. And so I actually prefer the combined gas law because it involves all of the other gas laws. I don't have to remember what is what. I just have to know, oh, P1V1 over T1 equals P2V2 over T2, and then I'm set for every equation that I would ever need to use based on this. And so that's the combined gas law. And so that's what we're going to work on today. Okay, so let's take our notes. Again, we're on page M107, and we're going to talk about deriving the combined gas law. So we're just going to kind of do what we just did. So we said that we have P1V1 equals P2V2. We knew that we had V1 over T1 equals V2 over T2. And we also had P1 over T1 equals P2 over T2. And if we combine all of those together, we get the combined gas law, which is P1 V1 over T1 equal to P2 V2 over T2. Just like before, the same rules are going to apply. The temperature must be in Kelvin. And so remember, in order to get Kelvin, we're going to take Celsius plus 273 in order to get that unit of Kelvin for temperature. And just like before, the volumes, it doesn't matter if they're in milliliters or liters as long as they're both in milliliters, both in liters. Same thing with pressure. Doesn't matter if they're in ATMs or mmHg or kPa, they just both have to be in ATM or both have to be in mmHg. And so while we're there, let's just go ahead and remind ourselves that 760 mmHg is equal to 1 ATM, which is equal to 101.3 kPa, just in case that comes up. And again, mmHg and torr are the same. And the other thing that could potentially come up is that term STP, or standard temperature and pressure. And if you ever see that, the temperature is going to be 0 degrees Celsius, and the pressure will be 1 atm or its equivalent if you get a value saying STP. And those are just reminders. They may or may not show up for us today, but we just want to remember them, and they're always available to you on our reference posters. Okay, so we've kind of answered the first question. How was the combined gas law derived? We literally just combined all of them together to get P1 V1 over T1 equals P2 V2 over T2. So how do we solve for a missing variable? The same way that we've always solved for missing variables. We're going to make our list when we read our problem. We're going to determine what we're looking for. And then cross multiply and divide. What a lot of students prefer to do is, because they don't like it set up this way, they actually kind of rewrite it. And so if you think about cross multiplying, they would say P1 V1 T2 equals P2 V2 T1. And they prefer that. So again, we just took P1 V1 times T2 and then P2 V2 times T1. And that's an equivalent relationship. And they prefer to work from this because they don't have to deal with a fraction. Doesn't matter to me what you prefer. Just know that you're always going to get this as a reference. You would have to know to cross multiply in order to get that. Okay, so how do you solve for a missing variable? Well, let's just do a practice. Let's say that we have, so missing variable. To solve for a missing variable, because you're always going to have at least one missing variable, let's say that we have P1, V1, T1, P2, V2, and then we're looking for T2, so that's our X. So just like always, we're going to cross multiply and divide. The difference is that the cross that has your X in it always will go to the denominator. So the X side will always go to the denominator. X to the denominator, which means you'll always have 3 values over 2 values. So for this one, what we would end up writing is we would take the cross with 3 values, so P2 V2 T1 divided by the cross that only had 2 values, P1 V1, and then that would give us our answer, and you can see that the units would cancel, leaving us with a temperature value. So the X cross always goes to the denominator. That's one way you can solve it. If you're going to set it up in this equation, then you would just kind of do what you would do to solve any type of algebraic equation. You would have plugged in, you're looking for T2, so you would have been able to plug in a value for P1, V1, P2, V2, and T1. You would have had all of your values here multiplied. You could have simplified these, leaving this as your X, and then divided the P1 and V1 over, and you would have ended up with the same formula. So this is one of those many different ways to solve a problem situation. You get to pick what works best for you. You can either use the equation set up as the fraction, which is the actual combined gas law, or you can use the simplified version, which is the same thing. It just gets rid of the fraction, and that's a little bit easier for some students to use. Okay, so what if a variable type isn't mentioned at all? So variable not mentioned at all. And by at all, I mean ever. Like there's no mention of temperature in the problem, or there's no mention of volume in the problem. Cross out the variable on both sides. So for example, if you have a problem and it's listing P1, V1, T1, P2, V2, T2, and they give you a pressure, and I'm just going to make numbers up. So let's just say they give you 1 ATM and then pressure 2 is 2 ATMs. Let's say the volume they give you is 10 milliliters, and then on the other side, the volume they give you is what you're looking, they're asking you for this one, what is the volume? And there was no mention of the problem of temperature at all. So you just cross it out. So how does that work with the problem? Well, if you cross T out, you just cover it up. Well, if you cover up T, you get P1 V1 equals P2 V2, one of the gas laws that we're already used to. Or what if it's, say, volume they didn't mention, where you just cover up the volumes? And so it becomes P1 over T1 equals P2 over T2, or this gas law. What if they don't mention pressure at all? Cover up your pressures, and you're going to get V1 over T1 equals V2 over T2, this gas law. So all 3 gas laws are here, and if you're not using a variable, you're getting rid of it, and you end up with one of your original gas laws. Last thing we didn't really talk about, we just want to make sure, is what must you always pay attention to about units. The first thing, and one of the most important things, is that temperature must always be in Kelvin. The relationship is not true if it is not in Kelvin, so you've got to make sure that that's true. And the other thing that has to happen is that the units must match. So units must match. So your volumes have to be in the same unit, your pressures have to be in the same unit. So each type has to be in the same unit. Units must match in type. Okay, so that's the combined gas law. Again, it's just all three gas laws combined. Sometimes you have to use all three parts, and so you're going to solve for everything. You can either use it set up like this or set up like that. I prefer to have it set up this way, so that's how I'm going to solve the problems today. But you can get the same answer using this setup because it's the same thing. Okay, so we're going to look at the worksheet that you have on page 106. I know that you've got some practice problems that you're also going to write on page 106, but this is the worksheet that's going to be given to you for page 106, and it's combined gas law practice sheet. The answers are provided for you. Some of them were wrong because I got this from the internet. So when I reworked them, I got the correct answers. And so I've given you the answers because I want to make sure that you're doing perfect practice. We're just going to look at two problems in particular, number 3 and number 4, to kind of help us out. And so looking at number 3 as an example, it says a child has a toy balloon with a volume of 1.8 liters. The temperature of the balloon when it was filled was 200 degrees Celsius and the pressure was 1.0 atm. If the child were to let go of the balloon and it rose 3 kilometers in the sky, where the pressure is now 0.667 atms and the temperature is negative 100 degrees Celsius, what would the new volume of the balloon be? So I'm going to take this problem and we're going to work through it. So we'll just do problem number 3 like this. Problem number 3. So the first thing I'm going to do is I always actually start out by saying P1, V1, T1, P2, V2, T2 on all of my problems. Even the problems that we were doing before in gas laws, if I was going to do them on my own, I would have set it up this way, and I would just ignore anything that wasn't used. Okay, so let's go through a problem and let's see if we can see a starting pressure. Well, it shows me that the initial or starting pressure for this system was 1 atm, and it was filled at 200 degrees Celsius, which I'm going to, before I even move on, go ahead and do my math there. That's 473 degrees Kelvin, because I don't ever want to put a Celsius answer down. And then the volume of this balloon was 1.80 liters before the child released it. After the child released it and it rose into the sky where the pressure is less, the pressure is now 0.667 atms, and the temperature is negative 100 degrees Celsius plus 273 gives me 173 degrees Kelvin. And again, I never want to put a Celsius answer in there. And it says, what would the new volume of the balloon be? Well, we know that the news are always the 2's, and so that's going to be the thing I'm looking for. So I'm actually going to use all 3 parts in this problem. Okay, so I'm going to write, so now that I have that, I'm going to kind of move this up so we can see better. So I have P1 V1 over T1 equals P2 V2 over T2. You can either write it this way or you can write it the other way. Doesn't matter to me. I'm going to solve it this way. Okay, so I'm going to just plug in my values. So I know that I have 1 atm times 1.80 liters. And actually, before I do this, let me show you a trick that I'm going to do. I'm looking for V2. So I'm going to circle V2. Well, I know that that X that I use has to go to the bottom. So that means that my actual equation is going to be P1 V1 over T2 times T1 and P2. So notice, remember, whichever cross has the variable that you're looking for, that cross goes to the denominator. So P1 V1 T2 over T1 and P2. It's just going to help me because now I can kind of cheat my way through the system. So P1 was 1.0, V1 was 1.8 liters, and T2 is 1.73 Kelvin. Divided by T1, which was 473 Kelvin, and P2, which was 0.667 atms. And that's just a trick that I use. I like to write the letters out first and then plug the numbers in so I don't have to take up so much space. The atms cancel, the kelvins cancel, leaving me with liters. And so I'm just going to plug this into my calculator. And so I'm going to take 1 times 1.80 times 173, and I'm going to divide that by both numbers in the denominator. So one of the ways I can do that with this calculator is take the first number, hit equals, and then divide again by the second number, hit equals. And so the answer that I get when I do that is 0.987 liters. And it looks like from my problem that I can have 3 significant digits. That's what I'm going to use, 0.987 liters. And if we go back to question number 3, that's the answer that we have. They use 0.98 liters, but 0.98 liters would be our answer for number 3. This is a problem where we used all 3 pieces of the equation. Okay, now let's look at problem number 4. Problem number 4, I'm going to slide this up, says a commercial airliner has an internal pressure of 1 atm and at a temperature of 250 degrees Celsius at takeoff. The temperature of the airline drops to 170 during flight. What is the new cabin pressure? So P1, V1, P2, T2. Okay, so I'm just going to read my problem and I'm going to plug in whatever values I have. So as I'm reading my problem, I see that the internal pressure starts off at 1 atm and the pressure is 250 Celsius. Go ahead and add 273 to that and I get 323 Kelvin. And the temperature of the airline drops to 170 degrees Celsius. Go ahead and do that math. 3, 4, 4. Oh, I need to go back to math. This is 523. When you add a 2, and a 1, it makes 5. Okay, so 523K, and this is 443. Okay. All right. So I have my 2 temperatures, and it wants to know what is the new cabin pressure. So it's asking me for the new cabin pressure. Do I see volume mentioned in this problem at all? No, it's not mentioned anywhere. I don't have any values for volume. So I can just cross volume off. Okay, so now that I have all of that in, let's go ahead and start with my combined gas law. P1 V1 over T1 equals P2 V2 over T2. And there's no mention of volume. So I'm just going to cross volume out completely. That means I have P1 over T1 equals P2 over V2, or an equation that I'm familiar with. Okay, so I am looking for P2. So I'm going to circle P2. And again, you can kind of do the whole cross multiply and divide, or for me, I like to take the cross of the 2 values that I have. So that's going to be P1 times T2, and then I'm going to divide that by T1. You can also say P1 times T2 equals P2 times T1. And since you're looking for P2, you would divide by T1. That's an algebra thing, whatever floats your boat for that. Okay, I just prefer cross multiply and divide. So P1 is 1.00 atms. That probably just really confused you, and I apologize for that. I got rid of V1, so it's P1 times T2. These are so easy to mess up on. Okay, so let's go back for a second. I had messed all of this up. So when I did my cross multiply and divide, it should be P1 times T2, and then my unknown side, this cross, ends up being the T1 on the bottom. Okay, and that's going to equal P2 because my volumes are completely gone. So I did it correctly here, but I just messed up there. Okay, so P1 times T2, which is 443 degrees Kelvin, divided by T1, which was 523 degrees Kelvin. My Kelvins cancel. And so, using my calculator, I have 1 times 443 divided by 523, and I get 0.847, which I can't remember from the original problem how many sig figs I'm able to have, but ATMs would be my answer. And so let's look back at our answer key, 0.85, 0.847 ATM. So we got the right answer by crossing out variables that we didn't use. So just as a super quick review, before we close this video out, we remember that the combined gas law takes all 3 gas laws, puts it together. The units must match just like they had to before. The temperature must be in Kelvin by adding 273 to Celsius just like it was before. We can cross multiply and divide, or we can rewrite the equation and we're going to solve algebraically both times. If you're going to use the cross multiply and divide version, just make sure that whatever cross has your x or your unknown in it, that cross goes to the denominator. If a variable is not mentioned at all anywhere in the problem, you can cross out the variable on both sides, and you're going to end up with one of your 3 original equations. We also just reminded ourselves of the conversion units for pressure, and then also the SDP meant 0 degrees Celsius, and that the pressure was 1 atm. Okay, hopefully this helps you be successful with the combined gas law.